Why do sailing stones need thin ice to move? Imagine stones that seem to move on their own across a flat, dry desert floor. It sounds like a mystery straight out of a story, but these sailing stones are real and fascinating. They are found in places like Racetrack Playa in Death Valley, where the ground looks completely still, yet stones leave trails behind them. So, how do these rocks get moving without any human or animal help? The secret lies in a very specific set of conditions involving thin ice. After rain or water from runoff pools on the dry lake bed, cold nights cause this shallow water to freeze into thin sheets of ice. These ice sheets are usually just 3 to 6 millimeters thick. That might sound tiny, but it's enough to form large floating panels that can move around. When the sun rises, the ice begins to melt and crack, breaking into big floating pieces that can be tens of meters wide. These floating ice panels are like natural sails, pushed by gentle winds. Winds of about 3 to 5 meters per second can push these ice sheets across the smooth surface. As they move, they drag the stones along with them, creating those mysterious trails. Beneath the ice, a thin layer of water forms. This water acts like a lubricant, reducing friction between the stones and the ground. Because of this slick layer, even large stones can slide slowly across the surface. The movement is very gentle, often just a few meters per minute, but enough to leave clear trails behind. The direction of these trails shows which way the wind was blowing during the event. Now, why is thin ice so important? If the ice were too thick or solid, it wouldn't break into floating panels. Without these panels, the stones wouldn't be pushed along by the wind. And if there was no ice at all, the dry, rough surface would create too much friction, stopping the stones from moving. The thin ice strikes a perfect balance. It's fragile enough to break into floating sheets but sturdy enough to exert enough force to move even heavy stones. So, in essence, these sailing stones relying on a rare combination of water, freezing temperatures, and wind. The thin ice acts like a natural conveyor belt, floating and gliding across the surface, pushing stones along. This process explains how these mysterious rocks seem to move on their own, making them one of Earth's intriguing geological wonders.